So, okay. So today we are going to be discuss that how the Karl Pearson coefficient of correlation going to be estimated. Okay, as we discussed in the earlier class, the correlation can be calculated with two methods. One is a graphing method, the second one is a mathematical method. Okay, in the mathematical method, there are many, like Karl Pearson coefficient of the correlation, like Spearman rank correlation, the least square method, like different type of the methods we can see in this mathematical relation. Okay, among these, today class we are going to be discuss the Karl Pearson coefficient of correlation. This is one of the mathematical method to use to estimate the correlation. Okay, Karl Pearson coefficient of correlation. Okay, here to measure the coefficient of the correlation, particularly through Karl Pearson, the first of all we have to understand the standard deviation. How we are going to be estimating the standard deviation with assumed mean. That we discussed in the last class. Okay, that we discussed in the previous class. Okay, previous class lo మనం already చెప్పుకున్నాం. Assumed mean ద్వారా స్టాండర్డ్ డీవియేషన్ ఎలా మెజర్ చేస్తాము అన్నటువంటిది ప్రీవియస్ క్లాస్ లో మనం చెప్పుకున్నాం. సెంట్రల్ టెండెన్సీస్ లో భాగంగా మనం చెప్పుకోవడం అన్నటువంటిది జరిగింది. ఓకే, హియర్ whenever we are talking about this particular aspect, please remember to measure the coefficient of the correlation through Karl Pearson, understanding the standard deviation is required. That we already discussed in the previous class. Okay, so without knowing the standard deviation, again we cannot understand the Karl Pearson coefficient of the correlation. Okay, so after knowing the standard deviation, if you enter to understand this Karl Pearson coefficient of the correlation, so it was developed by the Karl Pearson, a great British biometrician, developed this coefficient of correlation, and this method is mostly widely used in the practice, and it is denoted by the symbol called R. This is called R. So here the assets that are assets that the value of R must be either positive or negative. Okay, is interpretation of the different values of R like this, what we discussed already. This table also we discussed in the last one. Okay, if the value there in the positive, that is in the plus, we can say that there is a positive correlation. Okay, if R value is in the negative, that is in the minus value, we will say that there is a negative relation. Okay, negative relation among the variables. If you get the positive value, we can say that a positive relation between the values. Okay, if you will get the negative value, you can say that there is a negative value among the variables. Okay, based on the value, always either it will be +1 or in the -1. In between it will be there. Okay, based on the R value, we can interpret it like this. So this table already we discussed in the last class. Okay, that's why directly I am going to explain the Karl Pearson coefficient of the correlation. Okay, see, or nothing but Karl Pearson coefficient of the correlation. This is the formula. Okay, since we are explaining the mathematical methods of the coefficient of the correlation, there should be mathematical formula. Okay, this is the mathematical formula developed by the Karl Pearson to understand the what is called the coefficient of the correlation. So Karl, to know the value, the relation between variables, this formula should be used where R is equal to the Karl Pearson coefficient of correlation is equal to sigma xy divided by n into this is called sigma x into sigma y. This value, this is read as a sigma. So this will explain the standard deviation. Please remember. Okay, it will explain the standard deviation. This sigma nothing but standard deviation. So that's why already I told you to understand the what is called Karl Pearson coefficient of the correlation, we must understand the standard deviation. So sigma x divided by n into standard deviation of x, standard deviation of the y. X is a one variable, whereas the y is another variable. Because we are going to be explain the relation between two variables. X is one variable and y is another variable. Okay, for one variable we have to estimate the standard deviation, and another variable also we have to understand the what is called the standard deviation. So this is called sigma x. So sigma x nothing but a standard deviation of x variable, and sigma y nothing but standard deviation of y variable. That is, okay, sigma x nothing but standard deviation of series x, that is one variable, and sigma y nothing but standard deviation of the series y, that is y variable. Okay, so n nothing but number of pairs of the observation, that is number of observations, n nothing but number of observations. How many x variables are there, or how many y variables are there? Okay, so that is very good. That is number of pairs of the observation, where is R nothing but the correlation coefficient through product method, which was developed by Karl Pearson. And where is so here x nothing but x minus x bar. What is x bar? X bar nothing but arithmetic mean. Arithmetic mean nothing but sigma x by n, Okay, like y is equal to y bar. Nothing but arithmetic mean of y series. That is called sigma y by n, we can say. So that's why where is x is equal to x minus x bar, where y is equal to y minus y bar. Y bar nothing but this is arithmetic mean of y series, x bar nothing but arithmetic mean of x series. Okay, the x bar is equal to mean of x, y bar nothing but mean of y, mean nothing but arithmetic mean. Generally, any type of mean we can take, because there are 5: general arithmetic mean, geometric mean, harmonic mean, mode in, etc. Generally, we will take assumed mean, either arithmetic mean or mode or median, but in the most of the cases, we will take the arithmetic mean. Okay, we can take other mean also, but most probably we will take the arithmetic mean. That's why we are talking about x bar and y bar. Okay, so finally, so here what we have to know, if we want to know Karl Pearson coefficient of the correlation, we have to know the x bar, that is arithmetic mean of x series, and y bar, nothing but arithmetic mean of Y series, that we have to understand. So then we will get the X and Y. Okay, X and Y we will get. So then standard deviation for the both series. The standard deviation, both observations, X observations and Y observations, or X series or Y series. So both we have to understand. Okay, so we already discussed how we will find out the arithmetic mean, and we already discussed that how we will estimate the standard deviation. So based on that, we can use okay, this formula. Okay, suppose this is the problem given. Okay, find out or calculate the coefficient of the correlation through Karl Pearson. By using the Karl Pearson, find out the coefficient of correlation between these two variables. So there are 5 students, for example, in the class. Okay, in our class, okay, there are 5 students. Let's say example. Out of these 5 students, there are exams two subjects. One is a statistics subject and another is economic subject. Let's say example. Okay, their marks in the both subjects are like this. So for A, economics marks are 48, statistics marks are 45. B got 35 marks in economics, 20 marks in the statistics. C got 17 marks in economics and 40 marks in the statistics. The candidate D, he got 23 marks in economics and for 25 marks in the statistics. And the candidate E, roll number E, he got 47 marks in economics and 45 marks in statistics. So this is X variable, this is Y variable. Economics marks is called X variables and statistics marks are called Y variables. So here how many pairs are there? 1, 2, 3, 4, 5. 5 pairs are there. So nothing but N is equal to 5. Number of observation is equal to 5. Okay, please remember N is equal to 5 we got. So these are the marks given. So first what we have to get? We have to find out the X bar and Y bar. X bar. Let's say, for example, X bar. What is X bar? X bar is equal to sigma X divided by N. Y bar, nothing but sigma X divided by N. So sigma Y divided by N. Okay, we know already arithmetic mean. So that means sigma X bar nothing but sum of this observation is equal to sigma X. N is equal to, how many observations are there? 5. Okay, sum of this nothing but I think 170. Okay, 170 divided by 5, nothing but, so what is called 34. Okay, X bar nothing but 34. Okay, like that sigma Y nothing but sigma X, Y bar nothing but, so yeah, the Y bar nothing but sigma Y divided by N. Sigma Y nothing but sum of these two. Sum of these 5 is equal to 175 divided by 5, nothing but 35. So Y bar is equal to 35. Okay, that we know already. So based on that, this is the how we are going to be calculated. So we know these are the names, roll numbers A, B, C, D, E. Their marks in economics, X nothing but economics. Okay, so sigma X nothing but 170, already I told you. 170 by 5, nothing but 34, because X is equal to X minus X bar, already I told you. Okay, in the previous, so in the formula, but this is the coefficient of correlation sigma x y divided by n into sigma x sigma y. X nothing but here see what is x. So here x is equal to x minus x bar, y is equal to y minus y bar. So that's why here x is equal to x minus x bar. This is x minus x bar. How much x bar? X bar is equal to 34. Already told you. Like that, this is y is equal to y minus y bar. Y bar already 35. That's why directly I written here y minus 34. Y minus 35 is not is equal to, I'm sorry, y minus 35. So y minus y bar, or we can say y minus 35. Okay, that is what we can say. Okay, yeah, this is the x. Based on that, we got x bar. Based on that, we are going to be find out the x. So x is equal to, so this is x minus 34. That is x minus what is called x bar. So this is a x. 48 is a x minus 34. 48 minus 34 nothing but we can get a plus 14. Like that, x is a 35 minus 35 34 nothing but plus 1. X is a 17. 17 minus 34 nothing but minus 17. Please remember minus 17. X is a 23 minus 34 nothing but minus 11 we got. Okay, 47 nothing but what is called 47 minus 34 nothing but plus 30. So sum of all this value is called 0, because here see 14 plus value is 14 plus 1 15, 15 plus what is called 13 28, 28 plus values, minus values are also minus 17 minus 11 nothing but 28. So plus 28 minus 28 we will get the 0. Sigma x is equal to 0. Sigma x is equal to what is called 0. Like say here, what is x square? This is x, this is x square. Means this we have to square root. 14 square nothing but 136. 14 square nothing but 136. 196 answer. 1 square nothing but 1. 17 square is equal to 289 plus value we get, because minus 17 into minus 17. Minus into minus plus 17 into 17 to 89. Minus 11 is equal to plus 121. That is minus 11 square is equal to, and 13 square is equal to 169. So sum of these values is called sigma x square. Sigma x square is equal to 776. 776. This is so like that y. This is the y values. Sigma y is equal to 175. Y square nothing but y minus say y bar. Y bar nothing but 175. This is sum of y divided by number of n. So nothing but 175 by 5 nothing but 35. So this is y minus 35. So this is the y 45 minus 35 nothing but plus 10. 20 minus 35 nothing but so this is y 20 minus 35. So that is equal to, we will get minus 15 automatically. So this is 45 minus 35, no? So this is y is equal to 40 minus 35 nothing but plus 5. Okay, like 25 minus 35 nothing but minus 10. Like 45 minus 35 is equal to plus 10. So yeah, the plus value is 10, 5, 15 plus 10. What is to plus 25, and minus values are 15, 10, minus 25. Even sigma y also we got 0. Okay, 0. These are the y values. This is the y square values. Y square values. So yeah, y square nothing but this square 10 into 10 100, 15 into 15 225, 5 into 5 25, 10 into 10 100, 10 into 10 again 100. Minus values become a plus value, because minus 10 into minus is equal to plus 100. So minus 15 into minus 15 is equal to plus 225. So sum of this sigma y square is equal to 550. 550. So x, these are the x, these are the y. If we multiply this and this, we will get xy. xy. So this is 14. 14 into 10 is equal to 140. That is 14 into 10. So xy is equal to 140. Okay, like that 1 into 15. So 1 into minus 15, nothing but minus 15 only. Okay, like that 17 into 5. Okay, minus 17 into 5 is equal to minus 85. Okay, minus what is called 85. Okay, like minus 11 into 10. So minus what is called 11 into 10. So minus 11 into minus 10 is equal to plus 120, because minus into minus, it will become plus. So that's why 11 into 10, 110. So like that 13 plus 13 into plus 10 is equal to 130. So sum of all these values is called sigma xy. This is equal to sigma xy is equal to 280. Okay, this is the calculation. Now we got all the values. You know, what is the formula? Okay, so here, see, x bar is equal to sigma x by, already I calculated, say 170 by 5, that is equal to 34. So x bar is equal to 34. So when we are talking about y series, sigma y by n, sigma y we will get 175 by 5 is equal to 35. This is already I told you. So the formula to understand the correlation, Karl Pearson coefficient of the correlation, this is the formula, that is sigma x y divided by n into sigma x sigma y. Okay, whereas x is equal to x minus x bar, y is equal to y minus bar. Sigma x is nothing but standard deviation of x series. Standard deviation of x series. Sigma y nothing but standard deviation of y series. N is equal to number of pairs of the observation, we have 5. Okay, R is equal to coefficient of correlation of the Karl Pearson. So this is all this thing we know. So standard deviation sigma x is nothing but, we can say that sigma x square. Sigma x square. Sigma x square, nothing but standard deviation of x. Sigma y square is nothing but standard deviation of y. Okay, sigma x square, we know, I think 770 was there. Already we calculated sigma x square, 776. 776 was there. And sigma y square, that is standard deviation of x, is equal to, so already it was there, I think 550. Okay, 550, it was there, 550. So now we know all the values. Okay, all the values. Sigma xy, how much it was there? 250 or 280. Please remember sigma xy, 280. Okay, so sigma xy 280 and sigma x square, nothing but standard deviation of x, nothing but 776, and sigma y square, so nothing but sigma y is equal to 550. Okay, n we know 5. Okay, n we know 5. So if we observe, so R is equal to 280. Okay, 280. So this is finally we will get sigma x of with this one 776. Okay, this is 550. So 280 divided by 776 into 550 with square root. So that is equal to R That is equal to 280 divided by 776 into 550 with the root square is equal to 653.299. If you remove the square, we will get thus much. So then R is equal to 280 divided by this one is equal to 0.429. Okay, the coefficient of the correlation, that is R between economics and statistics, marks between the relation X nothing but economics marks and Y nothing but statistics marks. So R is equal to, so this role relation is 0.429, we can say. Otherwise 0.43 we can say. Okay, it is a positive value. Positive value, you know. Okay, already in the coefficient of the correlation, that is in this table, if the values will be like this, this is the interpretation. So we got a 0.43. 0.43, nothing but it will come under this one. If this is the thing, low degree of correlation between these two. Low degree of the correlation. So if the value may be positive or negative. Okay, it may be either positive or negative. If the value is in between plus 0.25 or minus 0.5 or 25 in between, that we can say that there is a low degree of correlation between these two variables, that is X and Y variable. So since we got 0.429 or 0.43, so we can say that there is a low degree of positive. Okay, since it is a positive value, we can say that positive correlation between economics and statistics. Positive, nothing but if economics marks will increases, statistics marks also increases. If the economics marks are decreases, the statistics marks are also going to be decreases. That is a positive relation. But how much of positivity it was there? There is a positive relation, but low level of positivity is there. Okay, like that we can find out the Karl Pearson coefficient of the correlation. Suppose if you got the minus value, suppose minus 0.429 we got, then we can say that there is a low degree of negative correlation. That means if one subject marks increases, another subject marks are going to be decreases. Like that, so we can understand, we can estimate the coefficient of the correlation between the two variables, this one. So like that we are going to be estimating the coefficient of the correlation, which was developed by Karl Pearson. Karl Pearson formula. Okay.